a circle. The circle of, let's say we have a radius, and then with the radius we form a sector. So we have an angle here, theta. So this is the area we call the arc. This is the arc. This length is the arc. So today we are going to be studying how to calculate the arc of a circle and the sector. So what I have here is just a picture of what it's like when you are drawing a circle. Then let's see how it's like. Say that this place is the place we call the arc. This is the arc. This is the what? The radius. And this is the angle, theta. So whenever, if you are to calculate the length of this arc, we know that the circumference of the circle is what? 2 pi r. So for this place alone, if we are calculating the length of this place alone, it will then be, we consider the angle, this angle. So when you consider this angle, that means the length of this arc, we can say the length of the arc we are looking at now will then be equal to theta over 360 times 2 pi r. This is just more like finding the fraction of the this very portion we are looking at, more like getting the fraction of it, because theta dividing this gives us a fraction of this particular area in the circumference of the circle. So which means if you are to calculate any, as the theta is changing, the fraction will also vary based on the angle of the theta, in order to get the circumference of the arc, the arc of the circular region. So the next thing we can do here, like I said earlier on, here we have a sector. The whole of this place is where we call the sector, that is all this area. So to calculate the area of this sector, since it's just a fraction of what we have in the whole circle, and we know that area of a circle is what? Pi r square. So to get this fraction of it would then be theta over what? 360 times pi r square. Just look at this thing very well. Look at it very well. And look at the other one very well. I want you to pick out something here. You find out that we are only working based on, we are calculating the factors, their fractions, the fraction of each of these, multiplying it with the words. This place is multiplied with the circumference. Here, the area of a circle is the total of this place. Then the fraction of this multiplying the area of the full circle also give us the area of the sector. This is the area of the sector now, of sector. That's the area of a sector. So this is, having this in mind, now we're going to be using it to solve some problems. That's what we're going to be doing at this moment. We're going to be solving problems that would, help us register this in our mind. Some questions we are going to be solving. The first one says we have a barrier. In this one, we have a barrier. This is the distance from this point to that point is 10 meters. And then say that how far does the end of the barrier move when it is raised through 60 degrees. For example, look at this. If it's raised through 60 degrees, let's have a picture of what it's like to raise it to 60 degrees. That means from this point, let's say we have this 13 and we raise it up. We raise it up towards 60 degrees. That is, this will be the angle now, the horizontal. We have the angle. Now the end, we're talking about the end. This is the end now. How far this end now down? How far is it from that place now down to this place? How far is it? So that raise through angle what 60 degrees. So looking at this now, it's more like, if you look at it very well, just looking at the distance, it means that it's more like getting the length of the arc. Remember, in a circle, remember what we had before. In a circle, this place is called the arc. So it is more like the arc. So that means for us to get this thing done, we'll be considering it based on the that length of the arc. So remember, the length of an arc you can calculate it by the theta times 2 pi r. That's how we can get the length of the arc. Now, this 10 meter will then serve as our radius, because it's happening from this point to that point. That's the radius. So what we do here, we have our pi should be 22.7 over 7. So our theta is already known, which is theta is 60 degrees over 360 times 2 pi, which is 22 over 7 times what? R. Our R now is what? 10. So what next are we going to do? Okay, let's just do the calculation and see what it will look like. We have 60 times 22 times 2 times 10. Then divide by 360. Divide by again. So our final answer is 10.48 cm. 10.48 cm. That is our final answer. That's the length it will move. So the next one we have here is more like, we have a square, and inside the square we have a quadrant. A quadrant, you know that in a quadrant is always angle 90 in a quadrant. Now let me just give you a picture of that. In a quadrant we have something that looks like this. So each of these quadrants is in a circle. We have quadrants. Each quadrant has 90, angle 90. So here now we have a square. A square is always all sides are equal. And the question said that the radius, we have to find this radius. Now, if you are to define the radius, we have the length of the square, which is 20. And the question said that if the area of the quadrant is half of the area of the square, find the value of the radius. Now we know from this diagram already. So what are we going to do here? Well, we have something like this. If we have something like this, now the next thing we are going to do, we'll compare them to say that area of the quadrant is half of that the square. If it's so, what are we going to do? We know that this place is more like, when we calculate this, we are calculating the area of a sector. This is giving us area of a sector. Then the total of everything here, the square will give us area of the square. So when we subtract them, let's see what it's going to look like. So okay, we're not going to subtract it this time. So what we are doing, we are comparing. We know that quadrant, the area of the quadrant is times pi r equal to the area of the whole square. area of the square over 2. That's the question. Half is half. So area of the square there will then be, area of the square will then be 20 times 20 over 2. Then the radius is what we don't know here, but we have the angle. Like I told you, the angle there is what? 90 degree. So we have our 90 degree over 360 times 2 over 7 times r square equals to. So what next are we going to do? And the next thing we are going to do now is to just simply multiply it through. Let's see how I'm going to do this to make it faster. Okay, 90 multiplied 22 divided by. So what we have here will be, I think I should move this thing up a bit. What we have here will be 0.7857 r square equal to, this multiplied to, we have a 20 times 20, we have 400 divided by 2, we have a 200. That's for the area. So now r squared, when we divide both sides, we'll move this over to this place. Then what we have will be 200 over 0.787 87857. So we divide through 0.7857. What we have here as our radius square is 254.55. So taking a square root of that, when we take a square root of this value, it will give us here we have 15.95 cm. Now this should be approximate to the nearest whole number. We have it to be 16 cm. So we have another question we're going to be looking at. This is going to be a bit complex, unlike what we have done so far. So the next one, but meanwhile, if you are joining us for the first time, we want to encourage you to subscribe to our channel. Subscribe to our channel, and you have a question, you leave in the comment section. We will always attend to you. And then don't forget to share. So let's go down to what we have. The next one we have. So this is the next question. Here we have we say that a windscreen wiper of a car sweep through an angle of 160 degree. The blade of the wiper being 25 cm long and the radius of the swept sector 10 cm as shown, just like what we are seeing here, 10 cm as shown in the figure. What area of the glass is swept? So look at what we have. We have this is 10 cm. This is the blade, where the blade is covering. This is the unswept region. So we say that what area, we want to find the area of this blade that is what? Swept. This area. So to do this now, it's more like what we're going to do, you just getting the area, the two areas, subtract from the other. So to do this thing, what are we going to do? Now note, from this point, you can say from this point to that place is R, big R. While this other one, from here to here, we can call it what? Small r, in order to make the work easier. So the big R will then be, area of the sector of the big R will be theta over 360 times area and then r square. Then we subtract it from the small one. We have theta over 360 times pi r small. So what are we doing? When we add up these two together, we get the big R, and that we get the big R, which is, if we add it up, we're going to be having a 35 cm. So what are we going to do here? They have the same angles. No, let me do it by this. Times what? 35 over 1. Okay, it will be 35 times 25. Okay, make it square. To be squared minus the same times 2 times what? 10 squared. So the next thing we're going to be doing here is to, perhaps I think that will make it easier. Let's just see if we can do the factorization of these things. If we factorize, you know that we have this same thing here, the same thing there, the same thing here, the same thing there. So we can remove all these ones out of this bracket. We have over 360 times, we have it right. And then out of the bracket, we then have big arrow minus small r in brackets. So this will make, I think this will make it easier for us. Anyway, let's work out these ones first. Then we'll come back and do justice to these ones. So let's see what we are going to get when we multiply through 106 times 22 divided by 7. We have a 1.368 all in brackets. Now this thing can also be factorized again. If we factorize it again, we have r plus multiplied by r minus small r. So if we do this is factorization that I'm doing here now. This arrow is for 35. We have 35 plus 35 plus 10. 35 plus 10. We have 45. Then we can then multiply it through, because it's going to multiply. Then we have another 35 minus 10. We have 25. All multiplied. We have 1 times 1.39. So when we multiply through 1.3968, we have, what we have is what? 4 cm in cm, right? So that's our final answer. This is what we have here. This is 1571.4 cm. This is the area of the y plane area. That is, the area that is plane is what we have here now. So you can see how easy and free the calculation is. I know perhaps if you have any question, you can always leave your question, because some students don't seem to know how to really handle this kind of thing. According to factorization, when you have a square of both angles subtracting each other, the value is the same thing as plus arrow plus these two angles, the two values multiply, adding together subtracting, multiplying each other will give you the same thing. So there are so many other ways. I think let me just show you a picture of what I mean so that it can be um, a bit easier for you to cope with. So let's say we have something like this. Let's say we have something like this where we have which number can I use now? Let's say I have 6 square minus 4 square. So to get the value of this now, to get the value is also the same thing. Or even if it's not without this together, to get the value is the same thing as 6 plus 4 and then 6 minus 4. So 6 plus 4 will give us 10. 6 minus 4. 6 minus 4 will give us what? 2. I think it's 2. Then 2 times this will give us 20. Let's see if we can get it in there. So 6 multiplied 6 squared will give us 36. I think so. 36. This other one will give us either 16. So when we subtract 6 subtract there we have 0, and then this subtracting we have what? 20. And see they are the same thing. So this is one of the ways of doing some work. If you don't want to go this way, just by factorization. Thank you so much for coming this far. Thank you. And if you have not subscribed to our channel, we want to encourage you to subscribe. And this question you see here will appear in the description of this very video. And also expect to see your comment. I will leave a question in the comment section there just for you to try your hands on how to solve this problem. Thank you so much. I'm so happy to have you here to this point. Alright. Remember to share. Thank you.